Good morning, it's Wednesday, April 29th, and this morning I'm going to show you how to take a sum or difference and express it as a single logarithm. So we're using the exact same properties as what we did yesterday. The only difference is now we're going the other direction. Yesterday we had a single logarithm and you were to write it as a sum or difference. Now they're going to give you a sum or difference and you're going to take it back to a single logarithm using the same properties, just going in reverse order. So to do that, if we have any numbers out front of the logarithm, which we do in this case, we're going to send the numbers that are out front back to being exponents. So that 1/2 will be sent back to being an exponent. The 3, same story. So now I'm here. And then this is a sum. Well, what are we going to send a sum back to? We're going to send a sum back to being a product. And then as I showed you in yesterday's lesson, any variable or number to a fractional exponent can be written as a radical. So instead of leaving this as n to the 1/2, I'm going to write it as the square root of n, because as I stated yesterday, when you have a fractional exponent, the top number is the power and the bottom number is the root. So n to the 1/2 is the same thing as the square root of n. And even though we never write it on a square root, there's actually a 2 there. So I'm going to write this final answer, and I'm also going to put this in alphabetical order. Order doesn't matter when you multiply two objects together. So I'm going to put in alphabetical order and put m cubed times the square root of n. It almost looks like it's the cubed root times the square root of n. So there's the answer to that problem. I sent it back to a single logarithm. So, same story, we got to take the sum or difference, in this case it's a difference, and send it back to being a single logarithm. If you have numbers out front, you're going to send them back to being exponents. So, have log a to the 1/3 minus log 2. And then, to undo subtraction, we're going to send subtraction back to being a quotient. And whenever we send it back to being a quotient, whatever comes first in the problem has to be written on top in the numerator. So this is going to be log a to the 1/3 over 2. So we send subtraction back to division, back to a quotient, and then same in a similar story as how I finished up the previous problem. Instead of leaving it as a to the 1/3, I'm going to write it as the cubed root of a. So, this is our answer, the log of the cubed root of a over 2, because we send subtraction back to division, back to being a quotient. And this even works, these properties even work with natural log. Logs and natural logs have the exact same properties. All right, yesterday I talked about the product rule, the quotient rule, and the power rule. The product rule says you can send a product to addition. Well, in a similar fashion, you can send it back, and you can send addition back to being a product. The quotient rule says if it's a quotient in logarithms or natural logarithms, a quotient, if it's division, you send division to subtraction. Well, in a similar fashion, if we're going the other direction, you send subtraction back to division. And then the power rule that I showed you yesterday, any exponent that you have in logarithms or natural logarithms can be thrown out front. Well, if you have any numbers out front, you can throw them back to being an exponent. Those properties go both ways. So, and they work for logarithms and natural logarithms. This is natural logarithms, abbreviated LN. It's subtraction. Well, we're going to send subtraction back to being. We're going to send it back to division. And whatever comes first has to be written on top. So we have the natural log. This is written first, so this has to be written on top. So now we're here. And then this actually algebraically simplifies because x squared minus 4 is the difference of two squares. So x squared minus 4 factors to be x plus 2, x minus 2. And so now I'm here. And so it algebraically simplifies because the quantity x plus 2's wipe each other out. And our final answer is the natural log of x minus 2. Last problem. Alright, expressed as a single logarithm. We have numbers out front. What are we going to do with them? We're going to send them back to being exponents. Notice there's a little subscripted guy written on these logarithms that has a subscript of a. That being the case, you have to keep writing that throughout the problem. So I sent the numbers that we had out front back to being exponents. Alright, undoing the power rule, so to speak. This is addition. Well, what are we going to send addition back to? We're going to send addition back to multiplication, back to being a product. So, we have x to the 2/5, and then we're going to multiply that by y to the 1/3. And then, anytime we have a fractional exponent, I'm going to take it all the way to writing it with a radical. So the final answer here, remember top number is the power, bottom number is the root, top number is the power, bottom number is the root. So this is going to be written as the 5th root of x squared. And then this is going to be the cubed root of y. Those guys are getting multiplied together. So we send addition back to multiplication. And basically today's lesson, we're just going in the reverse order as what I taught you yesterday. Have a great Wednesday.